The question is how to find out whether a particular equation is unidentified, just identified, or over-identified. The question is, consider the following system of equations. We have three simultaneous, we have the three equations. Y1 is equal to alpha naught plus alpha 1, y2 plus alpha 3, y3 plus alpha 4, x1 plus alpha 5, x2 plus u1. Okay, so u1, u2 and u3, these are the residual terms, alpha naught, beta naught and lambda naught. These are the constants. Okay, so how do we find out the order condition for identified, exactly identified or under identified? For that we use the order condition. Okay, so for order condition, what we use the order condition? Order condition tells us, and let me write it here. Let me denote some variables here. Let us say k. What is k? Or let me write it here, k minus m, and we have another g minus 1. Now let me explain all these terms. What is meant by k? This k denotes the total number of equations. This k denotes the total number of variables, whether they are endogenous or exogenous, in our model. M denotes the number of variables in a particular equation. G denotes the total number of equations in the model. Okay? Now, if we get it, the equality sign, then we have exactly what we call identified. The particular equation is exactly and what we call identified if this equality signs holds. If we have k minus m, if it is less than g minus 1, in this case we say the particular equation is unidentified. Similarly, if k minus m is greater than g minus 1, in this case we have our identified, the particular equation is our identified. Okay, now we are being told about the first equation. Okay, what will be the first equation? In the first equation, so what does k denote? K denote the total number of variables, whether they are endogenous or exogenous. Exogenous variables, as you know, they are determined outside the model, and endogenous variables are determined inside the model. So in particular, in the first equation, what will be the value of k? Rather, the value of k will be the total number of variables in the model. So we have y1, y2, y3, and then we have x1, x2, and I guess x3 is also somewhere. Okay, we have x3, x2, x1, and we have y1, y2 and y3. I guess total number of variables, whether they are endogenous or exogenous, or 6. These alpha naught, beta naught, gamma naught, these are the constants, and u1, u2, u3, these are the residual terms. They are not neither endogenous nor exogenous. Okay, so total number of variables in the equation, rather in the model, that is the value of k. K comes out to be 6 minus what is m? M denotes the number of variables in a particular equation. Since we are being told about the first equation, what are the variables here? y1, y2, y3, x1 and x2. So we have 1, 2, 3, 4, 5. So m will be 5. Now g, total number of equations is 1, 2 and 3. Let's write it here, 3. Okay, now 6 minus 5 is 1 and 3 minus 1 is 2. So this inequality holds. Okay, so that means first equation is unidentified. Okay, so the correct option should be A option here. Now here we can also see what about, so the question was only about the first equation. Let us say we are being told about the second equation. So what will happen in the second equation? So total number of variables in our model are 6, and total number of variables in the second equation are 1, 2, 3, 4. So in this case we will have 4. So let us write it here 4. So here first we have 6, and m denotes the number of equations in a number of variables in a particular equation, which is 4. So 6 minus 4. Here we have g minus 1. So we have 3 minus 1. In the second equation, 6 minus 4 is 2. 3 minus 1 is 2. So the second equation is just identified or exactly identified. What about third equation? So in the third equation we have 1, 2, 3, 4. Again we have 4 variables in third equation. So we will have 6 minus 4, and here we have 3 minus 1. So we get 2 is equal to 2. So the third equation is also just identified.